Hello and welcome back. We have understood k-means clustering and how it works, and we have understood what is within cluster sum of squares. Now let us try to understand how to select the best k. On a k-means clustering algorithm, how to select the best number of clusters. And if a data set is given, what is the best number of clusters that data set can be split into, or best number of groups the data set can be split into. There are two approaches. One is elbow curve and second is Shillhote score. The approaches works, for some data sets elbow curve works and some data sets Shillhote score works. So that's where you need to learn both. So the elbow curve is a learning curve between the number of clusters and within cluster sum of square. The way we do this is we take k is equal to 2 and try to build a model and calculate WCSS. K is equal to 3, try to build k-means clustering model, and then take WCSS. K is equal to 4, build a model, take WCSS. Like that we build maybe 5-10 models there, and then try to plot a graph between these two. And from the graph, wherever the drop is high, rapid drop is there, that is the best cluster we will choose as. That is the best k we choose as. The optimal number of clusters is when the total WCSS drops radically. Okay, so here from 2 to 3 the drop is radical, but from 3 to 5 is also there, but it is not this radical. So we say best k is equal to 3. Okay, this is like an elbow, right? If you see that as an elbow, right? So that's where you call it as an elbow curve. Okay, sometimes what happens is this curve comes very smooth. In that case, you may have to go with the Shillhote score. What is Shillhote score? Shillhote score is a number between -1 and +1. If a data point, Shillhote score is calculated for each data point in the data set. If you pass a model, if you pass a data set to k-means clustering algorithm and then try to calculate Shillhote score, the Shillhote score method will calculate score for each data point. That score is going to be between -1 and +1. If the score is close to 1, that means the data point is far from the closest cluster. If the score is close to 0, that means the data point is on the border of the second cluster, other closest cluster. If the score is close to -1, that means the data point is overlapping with the other cluster. So if there are two clusters like this, A and B, if you choose a data point D somewhere here, then the D's Shillhote score is going to be +1, close to +1, not +1, close to +1. If you chose a D data point here, somewhere here, right, this is the closest cluster, right? So the score is going to be close to 0. If clusters are like this, overlapping on each other, and if you chose D somewhere here, then the Shillhote score is going to be close to -1. That's how it is going to be. And if you calculate the average of all the Shillhote scores in all clusters, you will get one score for total data set. The point is, you chose to do two clusters of the data set. K is equal to 2, you have chosen, and built a model and calculated Shillhote scores for all the data points. You took average of all the Shillhote scores, and now you have got a number close to 1. That means the clusters are well separated between each other. So the separation distance between cluster is the point of average of all the Shillhote scores of data points. So if the all Shillhote scores average is close to 0, that means the clusters are kind of close to each other. The separation distance is less. If it is -1, that means the clusters are overlapping. So Shillhote scores and the average Shillhote score gives you a good idea of how clusters are being divided into. Okay, and there is a concept called Shillhote plot. We'll understand that later. But we understood the two approaches to select best k, where the total average Shillhote score gives you +1 or number close to +1. That cluster is best. But on this data set, right, for 2 clusters the Shillhote score is high, close to 1. For 3 it dipped, for 4 it dipped, right, it is dipping. So Shillhote score is not the best way to choose k here on this particular data set. Okay, on this particular data set, Shillota score is not the best one. Elbow curve is the best one. Okay, because it is actually showing you the steep decline in WCSS when you did the 3 clusters. So on Shillota score, it is never raising, so it should raise. Actually, the bar, wherever the curve raises, that's the cluster number of clusters we try to choose, because the separation should be very neat. The separation distance between clusters should be high. That means the average score should be close to 1. We have taken number of clusters, and on y-axis we have taken the average Shillota score. What is average Shillota score? All data points will have Shillota score. You take average of all those for each k, and then try to do learning curve between number of clusters and average Shillota score. Wherever the Shillota score is high, that number of clusters are the best k. Okay, these are the two approaches. We'll see these concepts with a simple data set in coming session. Thank you.